All right, so we're going to do some of these problems together. Let's look at the first one. We have number 1 says zinc and lead nitrate react to form zinc nitrate and lead. Okay, well, what is zinc? I come to my periodic table, I find zinc is Zn. It is not in the diatomic 7 that makes that 7 shape there. So it's a metal. It can exist as its own. And then I have lead nitrate. Well, I know that nitrate is a polyatomic ion. We had this list. Nitrate was NO3 minus 1. So that tells me that I'm going to have to create this compound. I'm going to have to make sure that it is correct. And I look at the same page, the backside. Lead can be a 2 or a 4. And thankfully in our question, we're told that it is lead 2. So Pb plus 2. I'm going to do the crisscross method. My charge becomes my subscript on the other element. So lead doesn't get a subscript because it was just 1. Nitrate, I have to put in parentheses because that 2 is going to come down and be the subscript there. And then it reacts to form zinc nitrate and lead. All right, so what ion does zinc form? I can come back to my cheat sheet. It forms a plus 2, so conveniently, it's just like lead. This is a single replacement. I'm going to change the metal for the metal. Zinc nitrate. It's a parentheses, I promise. And lead. So then I look and I count my atoms. I have 1 zinc in the reactants, 1 zinc in the products, 1 lead in the reactants, 1 lead in the products, 2 nitrates in the reactants, 2 nitrates in the products. I went from words to a balanced chemical equation, and I'm going to go as far as to say this is single replacement. So practicing those types of reactions that we did. Okay. All right. Let's go ahead and do 2 together, and then we're going to skip down and do 6 together because 6 is a little more complicated, but we'll do 2. 2 aluminum bromide and chlorine gas. Okay, wait. Chlorine we just talked about with the diatomic atoms. So if I look aluminum bromide, that "ide" ending tells me that we have an ion situation. I look back at my cheat sheet from a zillion years ago. Aluminum makes a plus 3 charge. Bromine, which was the bromide, we could come to our cheat sheet, makes a minus 1, but we also know that's in the halogens, the group 7. So again, we're going to crisscross. We have aluminum AlBr3 plus chlorine gas. That was one of the ones we just talked about. Chlorine gas was diatomic, so we know that chlorine has to have the 2 there to form aluminum chloride. So we know that chlorine and bromine are in the same family. So we're just going to literally switch out those symbols there. We still need the 3 because aluminum's still going to make a plus 3 ion. Plus bromine gas. Now, bromine is one of our diatoms as well, so we want to be mindful of that bromine will never exist by itself. So we're pulling in all this stuff that we know from all the whole year almost. And then we have to balance it. Well, we're going to have to use our common denominator thinking in this. So we're going to do a 3 here and a 2 here. And for the same situation. So we're going to do a 3 and a 2, and let's count. Aluminum, bromine, chlorine. I have 2 times 1 is 2. 2 times 3 is 6. 3 times 2 is 6. 2 times 1 is 2 for aluminum. For bromine, 3 times 2 is 6. For chlorine, 2 times 3 is 6. And we're balanced. And we look, it is also a single replacement. So we'll just make note of that for good practice. Okay. All right, so like I said, we're going to skip down to 6 for sake of time. I do want you to do some of these on your own. Okay. So 6 is calcium hydroxide and phosphoric acid react to form calcium phosphate and water. That's a lot of science words in there. So calcium. Where do I find calcium on the periodic table? If you're totally lost and you don't know, start with what you do know. You know what calcium is. Okay, calcium's right here. Calcium's going to make a +2 ion. Hydroxide, we know that we've been using our polyatomic ion sheet, so we're going to look there in a second. So we're going to start with that. Calcium is a +2. I'm going to look on my polyatomic ion sheet. And there's hydroxide. It's OH minus. So you're pulling in all these resources. OH minus. We're going to do that crisscross method again. So the charge becomes a subscript on the other. Calcium. And OH needs parentheses this time because the subscript has to go outside. So we got 1. Calcium hydroxide and phosphoric acid. You might say to yourself, I have no idea. What? So we'll leave that blank for a second. And we'll go to what, like I said, what you can tell. To form calcium phosphate. Oh wait, I remember this. Calcium's going to be a +2. Phosphate, remember we've already looked at our polyatomic ion sheet. Here's phosphate. PO4, 3 minus. So we're going to come up with this. Calcium, now phosphate needs the parentheses because we're going to put a subscript on the outside. Plus, I'm going to run out of space, water. All right, so we got to fill in this phosphoric acid. What do we got? OHs, and remember water can be HOH when you're looking at it and balancing the equation. So really, I need phosphates and hydrogens. That's what phosphoric acid is hydrogens and your polyatomic ion. So let's look. Hydrogen is going to be a +1. Phosphate is PO4 minus 3. So we're going to crisscross. H3, PO4. Okay. So the reason I wanted that right there is the reason I wanted to do this one is sometimes you're going to come across something in a word problem that you have no idea what it is. So you have to kind of process through. Okay, so this time, and I'm also going to show you on this one, when we balance or we're counting, we can leave polyatomics together. So we're going to count calciums, OHs, H's, and then PO4s. And that'll just make life way easier for us as we're counting. So we have 1 calcium, we have 2 OHs, we have 3 hydrogens, we have 1 PO4, and then over here I have 3 calciums, I have 2 PO4s, and I just have 1 H and 1 OH. Okay, well, let's start with, I know I need 3 calciums here, so recount. 3 times 2 now is 6. All right. And I know I'm going to need 2 phosphates, so now I have 6. And I have 2. because this goes together. All right, so what do I need to do? If I need to get 6 hydrogens, I need to put 6 here. 6 times 2. Well, and then this is where you want to make sure that you're really clear. Because when you put the 6 there, you want to look at this HOH. 6 times the H is 6. 6 times the OH is 6. And now we have a balanced chemical equation. That one's a little complicated, right? Then when we look at it, especially if we keep this HOH, that concept in our head, calcium went with phosphate. Hydrogen went with OH. So this one is a double replacement. That's a terrible C. Okay. All right. So this worksheet that we're doing here has 8 problems on it, and we did 3 together. I want you to do at least 3 on your own and submit those 3, at least 3. That way if you get hung up on one, you can just skip it. Okay? So at least 3 on your own. I know we're cutting time short, but today's just short too. So